Okay, so in this part, we're going to continue our discussion with the normal distribution, but talk about the empirical rule. I love the empirical rule. I love rules. But this one's pretty special because we just talked about how the normal curve can be standardized, right? So this mean here, right, which is, the median as well. If I standardize, right, that's where the z-score is 0. But if I just looked at the fact in standard deviations away from the mean, remember one standard deviation from the mean, those were the inflection points, right? Well, it also gives another piece of information. It tells us like 68% of our data lies within one standard deviation. So if I took my calculated mean and added and subtracted one give or take, right? One standard deviation. This means 68% of my data is guaranteed to lie between those two values. Well, then what if I took the mean and added and subtracted 2 standard deviations from my mean? Well, that tells me that 95% of my data lies between these two values, whatever that is. I'm going to have to calculate it, like add and subtract values. Right? And then the last one is, what if I added and subtracted 3 standard deviations from my mean? You're like, that's really far. I know, and that's why we say 99.7%, which is basically all of your data, will lie within 3 standard deviations of your mean. So you could see a standard deviation that is 3 away from your mean, or a z-score, right? That is 3 z-scores away, either positive or negative. That's going to be a lot of your data values. So if I'm only counting that one like you did in your projects, give or take, that's 68% of your data. 95% of your data, give or take 2 standard deviations, lies there, and then 99.7 would be give or take 3 standard deviations. So all we have to do is just take our mean and add and subtract 1 standard deviation, take our mean, add and subtract 1 more, just go in order, and then do another one, 3. And this is just going to tell you 68% of your data lies between these values, 95% lies between these two values, and 99.7. Why is this so important? Because I don't even need to know what the data is. If I just was given a mean and standard deviation like you gave me in your projects, I don't need to know the data. I already know that 68% of the data is going to lie in 1 standard deviation. And I already know, I don't have to look at your raw data. I know 95% of your data is going to be within 2. I know 99.7 is going to be within 3. That's a guarantee. Now, it may be all of your data may lie in here. That means at least 99.7 will. So these are just guaranteed percentages. It's actually quite powerful. And because they're such definitive percentages, we can play with them. So the next piece of information is me playing with the standard deviations. Notice I cut this all into little pieces. If you added up all these percentages, it would be 100%. And notice here's the mean, right in that middle. And if I added and subtracted 1 away, that first give or take, add these percentages up, that's 68%. 34 plus 34 is 68. Take and add and subtract 1 more. Remember, that was 95%. And so if I took 95%, subtracted 68, divided into 2 pieces, I would get 13.5% for these pieces. And add and subtract 1 more. Okay, and that would be 99.7%. I would take 99.7%, subtract 95%, and split it in 2 and get 2.35% in each little tail. Now, I still am left with 0.3%, right? 99 0.7 from 100 is 0.3. So I have 0.3% in each of these, so I have to split that in half and I get the 0.15%. So this is the empirical rule guarantee, and then I just took all those percentages and chopped it all up. Okay, so let's take the peanut butter jars example that we use for finding like the variation or the spread problems back in chapter 2. So we have these 5 peanut butter jar prices, and we found way back in chapter 2 that the standard deviation was 26 cents and the mean was $3.68. So let's go ahead and find 1, 2, and 3 standard deviations from the mean. There's a couple of ways to do this, but let's just go ahead and use the formulas. So the first one, let's go ahead and do 68%. If we're 68% of our data will lie within 1 standard deviation from our mean. So just take the mean and add a standard deviation, and take a mean and subtract the standard deviation. So we get $3.68 and add 26 cents and then subtract 26 cents. So then I get $3.94 and $3.42. Okay, so this just means that 68% of peanut butter prices are within $3.42 and $3.94. So that's all it says. It says if when you just take one plus or minus, it's just 60% of your data will lie there. So if I did 95%, that's going to be 2 standard deviations from the mean. So take the mean and subtract 2 standard deviations, and then add 2 standard deviations. So you would just take 368 minus 2 times 26 cents. Minus 2 times 26 cents. And I'm just going to move this one over here a little bit to the right. So if I did that and put it in the calculator, I would get a value of $3.16. If I took 368 and added 2 times 26 cents, I would get $4.20. So this would mean that 95% of peanut butter prices are within $3.16 and $4.20. See if I can box that as I should. So then doing the 3 standard deviations away, 99.7%, I would just take the mean. Notice the method is the same. The problems will change, but the method isn't going to change. So here you would take the mean and subtract 3 standard deviations, and the mean and add 3 standard deviations. So you would just take 368 and subtract 3 times 0.26. And then 368 plus 3 times 0.26. And just so you can see it in the calculator, I'll do it. You can just put 368 exactly how it's on your paper. So minus 3 times 0.26. And then I'll hit second, enter, and then I'll just go edit that minus sign to be plus and hit enter. So 290 and 446. And then you would just say 99.7% of peanut butter prices are within $2.90 and $4.46. Okay, so I know what you're thinking. You're probably thinking, well, Darlene, you're saying 99.7% of peanut butter prices are 290 to 446, but you know what? All of them in this sample are within 290 and 446. And in fact, if I went to 95%, I would say all of them lie within $3.16 and $4.20. So this is an exact, and that's exactly correct. If you even thought that for a moment, you're not wrong. That's exactly correct. What the empirical rule says is that you don't even need to know the data. We just happen to see it. But if we don't know it, that we're going to be guaranteed that 95% of our data will lie between these two values. Did 95% lie within these two values? Yeah, and in fact, 100% lied in these values. So even without looking at data, this guarantee it just proved us right that it worked, that in fact 95% will lie in this between these two values. So it's pretty powerful because I mean, this is 5 peanut butter jar prices. But if I really took all the peanut butter prices in the entire world, I would have thousands and thousands and tens of thousands of prices of data. And so I don't need to look at all that if I can just have the mean and standard deviation and apply the empirical rule. So now let's go ahead and play with another application. And what we're going to do here is just play with the percentages. So here, an Acme company manufactures widgets. The distribution of widget weight is bell-shaped, and the widget weights have a mean of 51 ounces and a standard deviation of 4 ounces. Use the empirical rule to answer the following questions. The first thing I would do is draw the curve. Okay, where the peak is the mean. We know that the mean is 51 ounces. And we know with the empirical rule, we're going to have 3 standard deviations from the mean on the left and right. So let me go ahead and here's 1, 2, 3 standard deviations to the left, 3 standard deviations to the right. And then what I do know is that each of these segments here is 34%. Each of this piece here is 13.5%. And this last piece here is 2.35%. And the tails is 0.15%. And again, I'm not making this up. It was in our little note box right up here on page 82. Okay, so then I have all those percentages. Those are fixed. The percentages will not change. Only the mean and standard deviation, only the distributions change. So make a note, percentages will not change. Those are fixed. We don't get to change that. What we do get to change is our distributions, right? Before we were doing peanut butter. Now we're doing widgets. So let's go ahead and add and subtract our standard deviation. So 51 is our mean, and 1 standard deviation on each side would be 47 and 55, right? Add and subtract 4. And I really wouldn't use the same method as above. I feel that's timely. Go ahead and just take 47 and go 4 units to the left, right? Our standard deviation is 4, subtract 4, 43, keep going, 39. 55, add 4, 59, add 4, 63. So notice the standard deviation is just 4 every time. Now let's go ahead and answer the problem. So it says 99.7 of the widget weights lie between what two weights? Well, recall that 99.7 is 3 standard deviations from the mean. Okay, so let me go. Here's the mean. 1, 2, 3. 1, 2, 3. Okay, so 99.7% of the widget weights lie between 39 and 63 ounces. And I know what you're thinking. You're like, that's way too easy. I know. What percentage of widget weights lie between 43 and 63? So 43 and 63, it's this. Bound it together. Go inside, 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 in between, in between, in between. Okay, so what percent is that? I don't know. I'll just add them all up. So 13.5 plus 34 plus 34 plus 13.5 plus 2.35. So I would go ahead and add those all up and get 97.35%. And lastly, it says what percentage of widget weights lie above 47? Above. So let's do that in green. So where's 47? And above, let me do this. Here's 47. Above is left or right? Right. Now where do I stop? I don't. I take everything. Above means all the percentages to the right, including this tail. Okay, so there's a few ways you could do it, right? That above 47 would be 34 plus 34 plus 13.5 plus 2.35 plus 0.15. The other way is to see that this piece here where the mean is, that's half, right? So that's 50%. So you could say it's 50% plus this little piece here. Either way, it all works out. It doesn't matter because it's just 84%. So when you're doing these problems, the best thing you can do, and I hope you all are listening at this point, draw the curve, draw the percentages. These percentages will never change. Then do the x-axis because distributions will change. And then read the problem, identify it's between, so always go in between, add up all of them in between the two numbers or the number.